Technology in cycling is huge. It's almost getting to be like a Formula One style, with the amount of changes and wind tunnel testing and the things that you can change on a bike. There's so many different components that you can work with.
The implications of science, the difference that's made to the bike itself, to the equipment that we use, that its overall effect on speed and performance.
Technological advances and research from the Formula One and aerospace industries over the past 20 years have helped to develop the traditional steel tube bike into a high-tech aerodynamic piece of science-influenced design. The carbon fibre Lotus bike in 1992 heralded the advent of this new wave of development.
The Lotus bike came from a guy called Mike Burrows, who's his original idea, and he just said, well, wings is what people use in other industries to cut through air, so why do we make it a collection of tubes? We've got this wonderful new material, carbon fibre, that we can shape it however we like, and it will still be structurally sound.
When we started out and we were looking at making aerodynamic tubes out of steel, there was always so much that you could squeeze a round tube into an arrow shape before you would start to see cracks and things like that. With aluminum it got a little bit better, so you could make perfect shapes on a tube. But of course, while you join those tubes together, you were still quite limited. Those were just certain shapes that come together, and then you weld it. And now with carbon, also the joints in every part of the bike, you can shape it in whichever way you want, more or less. And then you just have to figure out how to make that shape strong enough so that you can ride it.
The material itself, carbon fibre, just opens up so many possibilities for construction.
Well, I think with carbon fibre, you combine a couple of advantages. The first one is it's very light for its specific stiffness and strength. So you can make something that's very strong, it's very stiff, so all the power you put into the bike goes into your propulsion instead of in deforming the frame, and yet it weighs very little. So that's the one major advantage. The other one is the form freedom. You can make any shape you want. So now it's possible to make tubes, very aerodynamic instead of round or almost round. And when you look at the periodic table, you see there's no element left that could do a better job of this. So also there's not really any reason to move to a different material.
The use of this revolutionary material necessitated the introduction of computer-aided design software to facilitate the creation of technologically advanced, light, stiff, but workable bikes.
When you look at computer simulation, you simulate for stiffness and strength. You can simulate what the weight will be. You can, if you have a carbon fiber, because a carbon fiber frame consists of say between 200 and 500 pieces of carbon, so small pieces that you lay on the frame in certain directions. So there, if a certain tube is 10 layers, you want to test what happens if we change this layer or that layer. So there's a lot of computer simulation that you can do to really speed up the development process.
And with the aid of computer modelling, you can tell the computer how many layers of this type of carbon fibre you've used, what resin. It will computer simulate the shape and bend it and say, yes, this is strong enough and stiff enough.
Its performance is directional, so you have the fiber, and in the direction of the fiber, the performance is very different from perpendicular to that fiber. So if you have a piece of carbon fiber and all the fibers are laying in a certain direction, it makes a lot of difference whether you put that piece on the frame like this or like this. It completely changes the stiffness and the strength. So the only way to do that properly is on the computer, so that you get already 90 or 95% to the final design. And then you make a prototype, you test it, you find out things that the computer missed.
Bringing together of several different technologies has been just revolutionised bicycle design.
With the combination of new materials and design software producing highly innovative bikes, research focused on the position of the rider to create a unit giving maximum performance as a whole. To this end, computational fluid dynamics and wind tunnel testing were introduced from other industries where aerodynamics is of prime importance.
The era that I worked in Formula One, the experimentation became very, very important. And that was because we were looking for really small incremental gains all the time. And I think that skill was probably the most important skill that I brought across to doing aerodynamic development in the bicycle industry. We've fitted many people now in this wind tunnel, over 250 amateur and professional riders, and the one thing that always comes home is that ultimately achieving the position is the fundamental requirement.
In achieving the optimum position, both speed and comfort are considerations. However, with maximum performance as the ultimate goal, one must take precedence over the other.
Well, I think when we're talking about, top performance sports, comfort is not really a consideration. So obviously there, if you could be faster in an uncomfortable position, you'll take it. So with power basically set by your lungs and your heart, it then comes down to what position can you get the most aerodynamic in, and is it at all possible to hold that position for whatever time that the event is.
Barney and I spend a huge amount of time at home in our garage, which is ultimately a process Chris Boardman went through, ironically, of looking at what I'm doing, taking photographs, using a mirror and deciding what looks to be the most aerodynamic, and then ultimately we can take that out every Wednesday evening in the summer onto a time trial race on the same course and test it. And ultimately the conditions do change a bit with the wind, but we can actually test out new positions, work out, looking at power files, looking at the time overall, whether the position has changed and helped or whether it's actually hindered.
When I was training, we used the wind tunnel, looking at finding the optimal position for each rider and the interaction with the bike itself. You might have a very aerodynamic bike that you produced, but the interaction between the bike and the rider is the most important thing, and that could have implications between me winning a gold medal and not winning a gold medal.
With continued investment in the science of the sport of cycling, what does the future hold for bike design and performance at elite level? And where will these ideas be drawn from?
I really see a trend towards further system integration. So I really see that the components and the wheels and the frame all come together and are designed together. We already started doing that, so when we design a frame, we already talk to the wheel manufacturer and see what they're working on, so that we know sure that in the end all those things work together nicely, both from an aerodynamic and from a structural point of view. So we see a big trend towards that, and the other big trend is electronics. We see that in shifting, we'll see hydraulics and brakes. So there's just some new technologies, not necessarily new in the world, but new, to the bike industry, that will start to take over certain functions of the bike.
There's a lot of learning from people who have parallels. So as you mentioned, the aerospace industry, the Formula One industry, people who face similar challenges, don't know about bikes, but there is common ground expertise. But also, you can also look for stimulus in the natural world, because there's billions of years of evolution there that has arrived at designs, and we don't know why. So for example, we know in the last 4 or 5 years we're exploring shark skins for hydrodynamics, and is the scaly dentical skin, when you put it under microscope, is that for replacement factor, or is that actually to do with micro vortices that help hydrodynamics? So it's all being explored. So there's a lot of good ideas just come out of the natural world if you look.